This is example number 2 from section 3.5. You probably listened to my videos before. I go through and I say what we're looking at in case you're wondering what video you're on. So we're still talking about direct variation or inverse variation. There's actually a third one, which is called joint variation. We're not to that yet, but joint variation is where you have more than one thing times your k value, more than one variable at the same time. So it's like direct variation 2 or 3 times. But direct variation was just y equals k times x without this n here. But you can have some things that come up that are direct variation with the variable to a certain power. So in this case, something to the n power. So when you see that in a word problem, it's going to say y varies directly as the nth power of x. So that's just a slight modification for how that's worded, where y is directly proportional to the nth power of x. So here's an example of that. The surface area of a sphere. If you're talking about the surface area of the sphere, it varies directly as the square of the radius. Okay, so what I'm going to want you to do is we're going to start off by we're going to write what I call a general equation. The general equation is going to be what's described at the very beginning of the problem, where it's going to describe to you what type of variation you're dealing with. Okay? So this would be my first step in doing that. So the surface area of a sphere, so I'm going to write this as, I'm just going to write S period, A period, equals, and it says varies directly. So varies directly means it's your constant times your variable. All right, if it said inversely, it'd be my constant divided by my variable. So my constant is going to be times something here, okay? And you can see right after that, it says directly as the square of the radius. So that's where the power comes in, because it's not just directly proportional or varies directly with the radius, it's the radius squared, okay? So right now, I have no numbers in here other than the squared part. All right, I have surface area, I got the other, what it's directly varying with, but I have a constant still in there. So then the second step is going to be on all these problems that I give you. So when we get to the test, you're going to have some on there. This is what I'm going to be looking for when I'm grading it. I'm going to be looking for you to write down the general equation first. Then I'm going to be looking for you to find out what k is. The way you're going to find k is that I have to give you at least one example of a radius in this case and a surface area that go together. That's why the next part, it says I have a sphere with a radius of 3 feet and the surface area is 36 pi square feet. So I'm going to substitute that in. I have surface area is 36, so the surface area is 36 square feet. On the other side, I have k times, and then I've got my radius squared. My radius, it says, is 3 feet. So when I substitute this information in, you'll notice the only thing missing is k. So that means I should be able to solve for it. If you simplify the right side, when you take 3 feet and you square it, that becomes 9 square feet. So I have 36 square feet equals 9 square feet, and then it's times k. If I want to get k by itself, I have to divide by the 9 square feet. I put the units in here because I wanted you to see that when you're getting the constant, everything should cancel out other than the numbers, because the constant does not have a unit of measure. All right, it's just a constant. So if I divide by 9 square feet on both sides, I forgot the pi, didn't I? I'm pretty sure that's why some of you are looking at me funny. That's fine. It was 36 pi square feet. So when I divide by 9 square feet, thank goodness I figured that out at this point. When I simplify that, the feet squared cancel out. The 36 over 9 becomes 4. I still have a pi in there. So I end up with k is equal to 4 pi. So that's step 2. Step 3 is a pretty simple one. all I'm going to do is rewrite. Now instead of having the general equation, I'm going to write, step 3, a specific equation, which just is me in a fancy way saying, rewrite your equation with the K value you found. So my equation now is going to be surface area equals, my K value is 4 pi, so it'd be 4 pi times r squared. And if you have studied surface area at all in previous classes, you would know that the actual formula for the surface area of a sphere is 4 pi r squared. Okay, so you can see that this fits with what I have. The final step is to actually answer the question that's about ready to ask me. It says, find the surface area of a sphere with a radius of 5 feet. So I'm going to substitute in 5 in for the surface, or for the radius, to find the surface area. So I'm going to have 4 pi times 5 feet being squared. So again, notice how the feet is being squared. Area is square units, so that's what causes the feet to end up being squared. So I have 5 squared, which is 25, times 4. 25 times 4 is 100. So my exact answer for the moment is 100 pi square feet. It's exact because I did not put in an approximate value for pi. Everything I did up there was stuff I could do without a calculator, and I can still do this part without a calculator, but I'm going to use a rounded value for pi. I'm going to use 3.14. That is not the actual value of pi. That's a rounded value. So that means after this, I would put surface area with a squiggly equal sign. 3.14 times 100 would be 314 square feet. So I have an exact answer and I have an approximate answer at the end of that problem.